9.3 from the chapter Statistics. So, in the first question they've given that the following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. We need to find the median, mean, and mode of the data and compare them. So they've given us the class intervals and they've given us the frequency. So first we're going to find mode. So when we're finding the mode, we need to know the lower limit of the modal class plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 times the class height. So the value of L is equal to the lower limit of the class interval that corresponds to the highest frequency, which is 20. So this is going to be f1. Lower limit is equal to 125. f1 is equal to 20. We know that f0 is the preceding frequency, so it's 13. f2 is the succeeding frequency, which is 14. Class height is upper limit minus lower limit, which is equal to 20. So substituting these values in the formula, we will get 125 plus f1, which is 20, minus f0, which is 13, divided by 2 times f1, which is 40, minus 13 minus 14, which is equal to minus 27, times the class height, which is equal to 20. So we will get 125 plus 20 minus 13 is equal to 7, and 40 minus 23 is equal to 13 times 20. And when we simplify this, we will get 125 plus 10.77, which is equal to 135.77, which is the answer to the mode. Next, we need to find the median. And when we're finding the median, we need to know the lower limit of the median class plus n by 2 minus cf divided by f times height. So n by 2 is the cumulative frequency of the data, which is 68. So 68 is the value of n by 2 would equal 34. So now that we know the value of n by 2, we need to find the median class. So since we know that the value is n by 2 is 34, we need to find a value in the cumulative frequency which is not less than 34 but can be greater than 34. So we need to find the closest value which is not less than 34 but it is close to 34. So the first value would be 42. It is not less than 34 but it is greater than 34. So that means the median class would be 125 to 145. So the lower limit would be 125. And we know that the frequency is the frequency of the class interval to the corresponding class interval that is above the median class. So the frequency is equal to 20, and the cumulative frequency is the cumulative frequency that is above the class interval of the that corresponds to the frequency. Since that would be 22, so the value of the cumulative frequency is 22, and the class height is equal to 20. So when we substitute this in the formula, we will get 125 plus n by 2, which is 34, minus 22, divided by 20 times 20. 20 and 20 will get cancelled. 125 plus 12. 34 minus 22 is equal to 12. So 125 plus 12 is equal to 137, which is the median. Next, we need to find the mean. So we're going to use the step deviation method to find the mean. And in order to do that, we need to find the summation of FI/UI, which is equal to 7, and the summation of FI, which is equal to 68. So when we're using step deviation to find the mean is equal to the assumed mean plus the class height times summation FI/UI divided by summation FI. So the assumed mean here would be 135 because it's the middlemost value, so A is equal to 135, H is equal to 20, We know summation FIUI is 7, summation FI is equal to 68. So when we substitute the values, we will get 135 plus 20 times summation FIUI, which is 7, divided by 68. So we can cancel 20 and 68, and when we simplify this, we will get 135 plus 2.05, which is equal to 137.05, which is the mean. In the second question, they've given that if the median of the distribution given below is 28.5, we need to find the values of x and y. So they've given us the frequency. We need to find CF. We know that CF is F5 plus x, which is equal to 5 plus x, 5 plus x plus 20, which is equal to 25 plus x, 25 plus x plus 15 is equal to 40 plus x, 40 plus x plus y is equal to 40 plus x plus y, and 40 plus x plus y plus 5 is equal to 45 plus x plus y. So this is equal to 60, because the cumulative frequency would be equal to the sum of the frequencies given. So we can write 60 is equal to 45 plus x plus y, and 15 is equal to x plus y. So they've given us that the median here is 28.5. So we know that through the formula, 28.5 is equal to L plus N divided by 2 minus CF by F times H. And since the median is 28.5, that means the class interval, that means 28.5 will lie between the two numbers in the class interval. So we know that 28.5 lies between 20 and 30. So that means 20 to 30 is the class interval. So then we can say L is equal to 20, F is equal to 20, CF is equal to 5 plus x, and class height is equal to 10. So when we put these values in the formula, we will get 28.5 is equal to 20 plus 30 minus of 5 plus x divided by 20 times 10. 10 and 20 will get cancelled. We'll be left with 2. 20 can be brought over to this side, so we'll get 8.5, because 28.5 minus 20 is equal to 8.5, which is equal to 30 minus 5 minus x. So 8.5 is equal to 30 minus 5, which is equal to 25 minus x. So the value of x is equal divided by 2. So when 2 is brought over to the left-hand side, we will get 8.5 times 2, which is equal to 17, which is equal to 25 minus x. So the value of x is equal to 25 minus 17, which is equal to 8. So now that we know the value of x is equal to 8, we can substitute it in this formula. So when we do that, we will get 15 is equal to 8 plus y. Y is equal to 15 minus 8, which is equal to 7. So x is equal to 8 and y is equal to 7. In the third question, they've given that a life insurance agent found the following data for distribution of ages of 100 policyholders. We need to calculate the median age if policies are given only to persons having age 18 years onwards, but less than 60 years. So in the original table, they've given below 20, below 25, below 30, and so on. And we will also notice that they've given us the cumulative frequency because it is in ascending order and the numbers continue to get bigger as we go down. So that implies that they've given us the cumulative frequency. So that means we need to find the frequency, and the frequency has not been given to us. But before we do that, we need to convert the below table into class intervals. Since they've said that the age begins at 18, we're going to start with 18 to 20, and then next they've given below 25. So that means it would be 20 to 25. And similarly, we'll have 25 to 30, 30 to 35, and so on. And since they've given us this cumulative frequency, we need to find the frequencies. So first we're going to write the first value of the cumulative frequency as the frequency for the first class interval. Next, to find the frequency of the second class interval, we need to subtract this value from this. So when we subtract 2 from 6, we'll get 4. When we subtract 6 from 24, we'll get 18. When we subtract 24 from 45, we'll get 21. 45 from 78, we'll get 33, and so on. So after we found this cumulative frequency and the frequency, they're asking us to find the median. So median is equal to L plus n by 2 minus cumulative frequency divided by frequency times class height. So n's value is equal to 100, so n by 2 is equal to 50. We need to find a value that is closer to 50, but is not less than 50. So the first value would be 78. So 35 to 40 would be the median class. Value of L is equal to 35. Frequency is equal to 33, which is the corresponding frequency to the median class. And the cumulative frequency is the cumulative frequency of the preceding class interval of the median class. So the cumulative frequency is equal to 45, and class height is equal to 2. So when we substitute these values here, we will get 35 plus n by 2, which is 50, minus cumulative frequency 45, divided by 33 times 2. So 35 plus 5 by 33 times 2. So 35 plus 10 divided by 33. So 10 divided by 33 will give us a value. However, here the class height, we need to keep in mind that since the first class interval is 18 to 20, however, the class interval for the other intervals, the class height for the other intervals are 5. So the class height would be 5, not 2. So 5 times 5 divided by 33 plus 35 will give us the median. So 35 plus 25 divided by 33 is equal to 35.76, which is the median. In the fourth question, they've given that the lengths of 40 leaves of a plant are measured correct to the nearest millimeter, and the data obtained is represented in the following table. We need to find the median length of the leaves. So we will notice that in the given table, it is not consistent. So we need to subtract 0.5 from the lower limit and add 0.5 to the upper limit, and so that the table is consistent, to make sure that they both have the same interval. So when we do that, we will get 117.5 to 126.5, and so on. And they've given us the frequencies. We need to find the cumulative frequency, which is 3, 8, 5 plus 3 is 8, 8 plus 9 is 17, 17 plus 12, 29, 29 plus 5, 34, 34 plus 4, 38, 38 plus 2, 40. So this would be the value of n. And we know that in order to find the median, we need to know the lower limit of the median class plus n by 2 minus cumulative frequency divided by f times class height. So we know the value of n is 40, so n divided by 2 is 20. We need to find a value in the cumulative frequency table that is closer to 20, but not less than 20. And that value would be 29, so its corresponding class interval will be the median class. So the lower limit of the median class is 144.5. And the frequency corresponding to the median class is its frequency, so f is equal to 12. And the cumulative frequency is the corresponding cumulative frequency to the class interval that precedes the median class, which is equal to 17. Class height is equal to the upper limit minus the lower limit, which is equal to 9. So when we substitute these values in the formula, we will get 144.5 plus n by 2, which is 20, minus 17 divided by 12 times 9. 9 and 12 will get cancelled in the 3 times table, and 20 minus 7 is equal to 3, so 144.5 plus 3 times 3 by 4, which will give us 144.5 plus 9 divided by 4, and 9 divided by 4 is equal to 2.25, so we will get 146.75, which is equal to the median. In the 5th question, they've given that they're asking us to find the following table gives the distribution of lifetime of 400 neon lamps. We need to find the median life of the lamp. So they've given us the frequency. We need to find CF, which is the sum of these two values, so 14 plus 56, 70, 70 plus 60, 130, so on. And when we're finding the median, we need to know the lower limit of the median class plus the value of n by 2 minus the cumulative frequency divided by f times class height. So the value of n is equal to 400, so n divided by 2 is 200. We need to find a value in the CF column which is closer to 200 but not less than 200. So that value would be 216. So its corresponding class interval would be the median class. The lower limit of the median class would be 3000. The corresponding frequency to the median class is a value of f, which is 86. The cumulative frequency is the corresponding cumulative frequency to the class interval that precedes the median class is the value of CF. So the CF value is equal to 130, and the value of h is equal to the class height, which is the upper limit minus the lower limit, which is equal to 500. So when we substitute these values in the formula, we will get 3000 plus n by 2, which is 200, minus class cumulative frequency, which is 130, divided by 86 times class height, which is 500. So we will get 3000 plus 200 minus 130 is equal to 70, divided by 86 times 500, and we'll get 3000 plus, we know that 70 times 500 divided by 86 is equal to 406.98. So when we add 3000 plus 406.98, we will get 3406.98, which is equal to the median life of a lamp. In the 6th question, they've given that 100 surnames were randomly picked from a local telephone directory, and the frequency distribution of the number of letters in the English alphabet in the surnames was obtained as follows. We need to determine the median number of letters in the surname, find the mean number of letters in the surname, and also find the model size of the surnames. So they've given us the frequency, and we need to find the values of the class cumulative frequency, xi, di, ui, and fi, ui, to find the mean, median, and mode. First, let's find the median. So in order to find the median, we need to know lower limit of the median class plus n by 2 minus the cumulative frequency divided by the frequency times the class height. N by 2 would be 100 divided by 2, which is 50. So we need to find the value in the CF column, which is closer to 50 but not less than 50. That value would be 76. So the median class would be 7 to 10, and the lower limit is equal to 7, and the frequency is equal to the corresponding frequency of the median class, which is equal to 40, and the cumulative frequency, the corresponding cumulative frequency to the class interval that precedes the median class is equal to the cumulative frequency, so CF is equal to 36. Class height is upper limit minus lower limit, which is equal to 3. So when we substitute these values in the formula, we will get 7 plus 50 minus 36 by 40 times 3. We'll get 7 plus 14 by 40 times 3, which is equal to 7 plus 1.05, which is equal to 8.05. Next, let's find the mode. So in order to find the mode, we need to know the lower limit of the modal class plus f1 minus f0 divided by 2f1 minus f0 minus f2 times class height. So the class interval is determined by the frequency, the highest frequency, which is 40. So the class interval would be 7 to 10. Lower limit of the class interval is 7. So L is equal to 7. F0 is F1 is equal to 40. We know F0 is the preceding frequency of F1, which is equal to 30. F2 is equal to the succeeding frequency, which is 16. And the class height is the upper limit minus lower limit, which is equal to 3. So when we substitute these values in the formula, we will get 7 plus 40 minus 3, which is equal to 10, divided by 2 times 40, which is equal to 80, minus 30 minus 16 times 3. So 7 plus 10 divided by 80 minus 46 times 3 is equal to 7 plus 10 divided by 34 times 3, which is equal to 0.88, and the value of the mode is equal to 7.88. Next, let's find the mean, and we're going to use the step deviation method to find the mean. And when we're using step deviation method, we need to know the assumed mean, the class height, times summation FIUI divided by summation FI. Summation FIUI is equal to minus 106. Summation FI is equal to 100. And we're going to take the assumed mean as 11.5. And the class height is equal to 3. So we're going to substitute these values in the formula. So we will get 11.5 plus 3 times minus 106 divided by 100. So we will get 11.5 plus 3 times minus 106 divided by 100, which is equal to 11.5 minus 3.18, which is equal to 8.32, which is equal to the mean. In the 7th question, they've given that the distribution below gives the weights of 30 students of a class. We need to find the median weight of the students. So they've given us the frequency, we need to find the CF. And after finding the CF, the last value is equal to n. So n divided by 2 is 15. We need to find a value in the CF which is closer to 15 but not less than 15, which is equal to 19. So its corresponding class interval will be the median class. So the lower limit of the median class is equal to 55. The corresponding frequency to the median class is equal to the value of f, which is 6. Cumulative frequency is the corresponding cumulative frequency to the class interval which precedes the median class, which is equal to 13. Class height is upper limit minus lower limit, which is equal to 5. So we're going to substitute that in the formula L plus n minus n divided by 2 minus cumulative frequency divided by frequency times class height. So 55 plus 15 minus 13 divided by 6 times 5. So 15 minus 13 is equal to 2. So 55 plus 2 divided by 6 times 5 is equal to 55 plus 1 by 3 times 5, which is equal to 55 plus 5 by 3, which is equal to 55 plus 1.67, which is equal to 56.67, which is equal to the median weight.